Welcome back to a new video. This video is going to be about optimizers. This video is going to be one of the videos that I will be adding into the Deep Learning with PyTorch series. You can reach to that playlist from the cards of this video. Let's start coding. In deep learning, optimizers are algorithms that play a crucial role in training neural networks by adjusting the model's parameters to minimize a predefined loss function. The goal of optimization is to find the optimal set of weights and biases that allow the neural network to make accurate predictions on the given data set. The optimization process involves iteratively updating the model parameters based on the gradients of the loss function with respect to those parameters. Gradients indicate the direction and magnitude of the steepest increase in the loss, and optimizers use this information to guide the model towards the minimum loss. So we have different optimizers. I'm just going to code it and then I'm going to talk about them one by one with their advantages and disadvantages. So what I'm going to do is I'm going to import Torch, and I'm going to import torch.neural network as neural network, and I'm going to import torch.optim as optim. In the end, I'm going to define a simple model like class simple model is going to be neural network module, and I will say define in it like self. I'm not going to use that on training or predicting side. I'm just creating for just setting things up. Super simple model self dot init like this, and then I will say self dot fc neural network linear 10 and 1. It doesn't matter. I will say define forward self x, and I will say return self.fcx. Okay, so after that, what I'm going to do is, this is a simple model. I'm just going to show you how we can use the common optimizers in PyTorch. So at the first step, we need to set the model. Like model is going to be simple model like this, and let's use the different optimizers. Like let's use gradient descent. Like I will say optimizer is going to be optimizer.sgd stochastic gradient descent model parameters, and we are going to set the learning rate at 0.01 like this. For example, the learning rate determines the size of the step taken during the optimization process. It plays a crucial role in controlling the convergence of the model during training. So we have something like optimizer, Adam optimizer, model.parameters, and let's set like learning rate 0.01 again. And at the last step we have more, but I'm going to just show you two more. We have something like adagrad. I'm going to show you like optimizer. We can set it like that, adagrad model.parameters, and we are going to set the learning rate at 0.01. and we have rms_prop like optimizer is going to be optim rms_prop model.parameters, and I'm going to set the learning rate as 0.01 again. So let's talk about them. At the next videos, you are going to see that we are going to set the optimizer like that, and we are just going to train our model. So let's talk about the optimizers we defined. At the advantages of the gradient descent, we can say like it's simple and easy to implement, and at the disadvantages side we can say make convergence slowly, especially on complex and high dimensional data set. So at the Adam side we can say, at the positive side we can say adaptive learning rates and efficient and widely used. At the negative side we can say requires tuning of hyperparameters, may not perform well on all data set. And at the adagrad side we can say, at the positive side, adaptive learning rates for each parameter, and at the negative side we can say can lead to a rapid decrease in the learning rate, making it less effective for sparse data. At the rms_prop side, for the positive side we can say adaptive learning rates addresses some issues of adagrad, but the negative side we can say still requires hyperparameter tuning, may not perform well in all scenarios. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the cards of this video or the link in the description.